Okay, hello everyone. In this video, we're asked to determine whether the language L, where L is a string over the alphabet AB, so in this case we don't have a form for the string W. The only condition we have on the string W is that its number of A's plus its number of B's has to equal 4 times its number of B's. Okay, so we need to determine whether this language L is regular or not, and then we need to prove our claim. Well, for determining whether this language is regular or not, what you kind of need to notice, and this is slightly tricky maybe, is that this can be rewritten in a different form. It can be rewritten as NA, so the number of A's in W, is equal to 3 times the number of B's in W. And so in this case, not only are we checking that the number of A's are equal to 3 times the number of B's, we also don't care about the form, right? So in some sense, if you had something like A 3n bn, that might have actually been easier than this example, right? Because this example says, oh, the A's and B's can be in any order, right? They can be in any order, but you have to track the number of A's and check that they're 3 times the number of B's. So, whoops. So here there's some kind of memory that's required, right? Some memory is required. And from the looks of it, right, because there isn't a bound on the number of A's or B's, the memory that's required will be unbounded. And so because it's unbounded, right, that gives me the idea that actually it's probably not regular. Okay, so I'm going to claim that it's not regular. And now I'm going to give you a proof. I'm going to prove. And I'm going to use the pumping lemma. So students usually get confused when it's a language that looks like this, because as soon as you completely remove the form from the language, they get confused and they're like, oh, well, what can I possibly pick for W? There's an infinite number of possibilities. Well, there's an infinite number of possibilities for the other languages, but this isn't any harder to prove than if you had something explicit like A. Here you're saying that the number of A's. So if you had something explicit like this, where the number of A's was 3 times the number of B's, this is no different than this, right? This is just, this language is a subset, right, of this language, which means that you can pick strings of this form against your opponent, right? So you're allowed, right? You're allowed to pick the form that you want. Okay. So namely, if your opponent picks the integer m, which we'll say strictly positive, so right, m is an integer, then what you can do, right, you can say, well, W has to have length at least m. If I pick a string where the number of A's is 3 times the number of V's, then that string will satisfy being an L, and it'll satisfy, well, now I need to also pick it so that it satisfies this condition. So what I can do is I can say, oh, well, I'll just pick W as A3M, BM, right? So clearly here, the number of A's is 3M, right? So the number of A's is 3M, and this is equal to 3 times the number of B's, which is 3 times M, right? So that's why this guy is an L. Okay, good. So this is the choice of W, that's an L. Now, my opponent is going to decompose the string, decomposes W into W's X, Y, Z, right? Where we have the standard restrictions on Y and Z, or on X, Y, and Y. There's never a restriction on Z, actually. Okay. And so what this tells us that Y is actually going to be a sequence of A's, right? Because y is going to be within the first m A's. And so if this is m, if I have 3 m A's and xy is within the first m, then for sure y is going to be just consisting of A's, right? So y is k consecutive A's, where k is greater or equal to 1. And now it's our time to play a move, our time to move. And so we have to pick a particular I. And so here, let's see. Well, if we just pump up by 1, so if we pick I is equal to 2, then we'll get W2 is a 3m plus k, bm. And so now what we need to show that the number of A's is not equal in this string 3 times the number of B's. Well, here the number of A's is 3m plus k, which is strictly greater than 3m. It's strictly greater because k is greater or equal to 1, right? And 3m is equal the number of B's, right? And so I have that the number of A's is strictly greater than, is strictly greater than 3 times the number of B's, right? The number of B's is m, so now I have 3 times the number of B's. So here I have the number of A's is strictly greater than 3 times the number of B's. And so that means that W2 does not satisfy this condition. Well, it does not satisfy this condition, which is logically equivalent to this condition, right? And so that means that W2 is not an L, which implies that L is not regular. Excellent. Okay.